Hello, 11th graders. So today we're going to finish 5-1 notes. Really quickly, I wanted to talk to you about your IAs. Last night, I sent out all of the feedback that I had written you guys, which includes a comments cover sheet, but realize that also on Turnitin, you have very specific, like, I've written on your graphs. And like, if you click on the comment, that's like a little speech bubble, you'll see them like all over your essay. If you click on that, there'll be a comment that I've left about that specific spot. So definitely feel free to go through and take a look at all of those. They might maybe help clarify the general comments that I made on your comment sheet, because I can't put all of the comments that I had on the comments sheet, because that's not the purpose of the comments cover sheet. So I know that some of you are super excited, and I know that some of you are feeling really bummed. I know all of you worked really, really hard on this essay, and so I hope you know that I've taken that into consideration. It's just that I'm not doing you a favor if I grade based off of the effort I'm seeing. I have to grade off of the product you've given me, because that's what the IB is going to do. They're going to grade off of the product you've given them, and now is the time before we do our real IA to learn and grow from that. I did curve this to be a little bit nicer than the IB would. So I will maybe send you out like what the average curve is for an IA. But this is definitely a little bit nicer of a curve than the IB would have given you, because you're still learning. So I have taken that into consideration, because this is your grade, right? Your GPA. And so I wanted to make sure that you weren't being graded as harshly as you would on a real IA. So all of that taken into consideration. If you are still upset, if you're still concerned, if you still have questions, reach out to me. Say like, can you please explain this to me? Or like, I don't really agree with that grade because I think that I showed it in this way. Or like, I think that the comments you left were not correct. Totally. Reach out to me. I want to hear what you think. I'm more than happy to explain them further. If I made a mistake and I didn't see something, I want to know, because I want you to do well. I really do. So I'm just trying to be there for you. And I hope that you know that I just want the best for you. So on that note, we are going to finish our notes for 5-1. So the second half about 5-1 is talking about the intersection of lines. So we're going to talk about it mostly only in 2-dimension. Realize that all of these could also be done via 3 dimensions, but that's not really the level of this course. So we're mostly just going to stick with a 2-dimension talk about intersections of lines. So just first things first, we have just 2 lines, and we want to find the point of intersection between the 2 lines. Finding the point of intersection between 2 lines, if we were to think about it, is the point where they agree. It's where they have the same X and Y value. It's a point that is on the first line, and it's a point that's on the second line, which means they have the same X and Y value. So the way that we find the same X and Y value is we have to treat it like what the X in one equation is the same X in the other equation. And if we treat it such that those X's are the same and those Y's are the same, then we will get an answer that shows us what those numbers are. That is why in these types of problems, we substitute, right? We're dealing with it as a system of equations. I want to substitute y for y, and I want to set negative 2x plus 1 equal to 3x minus 4. So that's what I'm going to do for A. Negative 2x plus 1 equals 3x minus 4. I'm going to add 2x to both sides and get 5x here. I'm going to add 4 to both sides and get 5 on the other side, which means I get that 1 equals x. Once I have found that 1 equals x, I'm going to plug it in for either of the equations because it's the same y value no matter what. It's good to plug it into both to double check that you got the right x value. And you get that y equals 3 times 1 minus 4. So y equals 3 minus 4, which is negative 1. Okay, so now you have an x value and you have a y value. It does say to find the point of intersection, which means we need to put it all together into a point, which is 1, negative 1. I'm loving all the colors. Okay, draw both lines on the same graph and label the point of intersection. We totally know how to graph lines. Na, 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 na. Na, 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 na. Okay, so negative 2x plus 1, I'm going to just like underline it in green, so know that that's what I'm going to be coloring it as. So plus 1 is your b, right? So it's your y-intercept, and negative 2 is your m, so it's your slope. I always start with the y-intercept and then build points off of the y-intercept. Actually, for you, it's going to be that way, I think. So I'm going to start at positive 1, and then I'm going to go negative 2 is negative 2 over 1, right? So if we have negative 2, that's really like negative 2 over 1, which means I go down to right 1. Or you could think of it as 2 over negative 1, which means you would go up to left 1. Either way would get you that down to right 1. I think that way. Well, you get the idea. So down to right 1, up to left 1. I think I can draw a line like that. Fantastic. Nope. Not a line anymore, but you get the idea. So now we're going to graph the other guy. I just really like yellow, so I'm going to go back to yellow. Y equals 3x minus 4. So I'm going to go to negative 4 and put my dot 1, 2, 3, 4. And I think that was negative 3, right? No, positive 3, which means I could go up 3, right 1, or down 3, left 1. And there you go. We have graphed both lines, and we want to label the point of intersection. The point of intersection is 1, negative 1. Sorry if I just give you motion sickness by doing that. There you go. Done. Find the x-coordinate of the point of intersection of the lines with the equations, and then they give you equations. Notice that one equation has a lowercase m and a lowercase b, and the other one has an uppercase m and an uppercase b. Since one is lowercase and one is uppercase, they're representing two different numbers. They're showing you like, hey, these aren't the same numbers, but x and y actually, if we're trying to find the point of intersection, are the same numbers. But we want to find out what is the x value. They haven't given you any numbers. So I'm sure most of you are like, what do I do? There's no numbers. You do it algebraically without any of the numbers. So we're going to do the exact same process we just did above, but without any of the numbers. A lot of you guys tend to freak out when you're being asked to find something and your answer is in variables. That's very, very common, and it's totally fine. Focus on what it's asking you to do. Find the point of intersection. Okay, well, when I find the point of intersection, I set these guys equal to each other, or I substitute in for each other. But since y has been isolated on both of them, I can then just set them equal to each other. So focus on what it's asking you to do and just kind of ignore the fact that there's no numbers. It's just variables. It's the exact same process. A. So we've got mx plus b equals capital Mx plus capital B. So, well, what did we do above? We combined the x terms together, right? So I might subtract lowercase mx from both sides. That means that this guy goes away and I'm left with b equals, and then it's mx minus mx. And then we've got plus b. I wanted to put those guys next to each other because normally I would combine them together, but I cannot do that here because there's no numbers. So instead, a different way of looking at it is that I'm going to take out x as a common factor there. I'm going to say, okay, well, if I have x for this guy, I'm going to be left with capital M minus lowercase m. And that's just what we did before. We took the exponents, the coefficients in front of x before, and we subtracted them and then put them with x, right? So now it's just representing that same algebraic process, just symbolically instead of numerically. I'm going to subtract capital B from both sides and get lowercase b minus uppercase b equals x times uppercase m minus lowercase m. And I'm still trying to solve for x, so I'm going to go ahead and divide both sides by that m minus m. So I get b minus b over m minus m equals x. That would be your x value. And the beauty of doing this, I'm sure a lot of you guys are saying like, well, why am I doing this without numbers? The beauty of doing this is you've just now made a formula. Anytime you have any two linear equations and you want to know what the point of the x value of the point of intersection is, it's that. It's the b value of one minus the b value of the other over the m value of the other minus the m value of the one. So you kind of switch your arrangements, unlike your slope formula. But it's a formula that you just made. It works for any linear equation you ever have, whether they're crazy numbers or easy numbers. It says to interpret your answer A considering different values of M and B and B. So interpret your answer would kind of be like what we've just talked about now. You could say that this is a formula for all, I do want you to write it down. I'm not going to write it down because writing on a tablet for me with a broken stylus is stressful, or just annoying. It's not stressful. It's just annoying. So you've created a formula for yourself for finding x values for any inputs of A and B. You've also found something that's very, very similar to your slope formula, except for now the orders are reversed between the two equations. It says interpret using different values. Yeah, I think that's good enough for an interpret.